You've studied the textbooks and understand how a binary search tree works in theory, but when tasked with writing the code from scratch, you freeze. You're left staring at a blank digital canvas. Transitioning from this baseline theory to a high-pressure interview at a company like Google or Microsoft requires a concrete, scalable study architecture. This system relies on 3 prerequisites. You need an active Leetcode account, a categorized digital workspace to track your progress, and a foundational grasp of linear data structures, like arrays, linked lists, and stacks. Once those are in place, you can move away from passive reading. This system forces you into active problem solving, which is the only way to survive the technical constraints of a real-world interview. The first step is a hard shift in your study ratio. Close the books and dedicate your time to solving 4 to 5 foundational problems for every topic you learn. Mastering these concepts is like building muscle in the gym. Lifting the same light weights every day won't result in growth. To get stronger, you have to systematically strip away the lighter plates and move to heavier, more demanding weights. In a digital workspace, this means moving as soon as a topic feels comfortable. Once you can solve easy problems without checking hints, manually apply the medium filter and move to the next level of difficulty. As the difficulty increases, you must avoid the most common failure point in technical prep, the memorization trap. Memorizing specific syntax just to get an accepted checkmark creates a false sense of security. That confidence disappears the moment an interviewer changes a single constraint, leaving you unable to adapt. You must measure your progress by your understanding of the underlying mechanics. This deep comprehension is the only way to handle novel interview scenarios without burning out. Treating every new coding challenge as a unique, isolated problem is a massive waste of energy. To scale your knowledge, you must shift your focus toward recurring problem-solving patterns. Stop categorizing your files and notes purely by the data structure used, like array or graph. Instead, group problems by shared logic. Take the sliding window pattern. Maintaining a specific range over an array remains the same, whether finding a maximum sum or longest substring. Internalize these boundaries to apply the single logic path to dozens of complex variations. Identifying these clusters dramatically reduces your trial and error time during a 45-minute timed assessment. Pattern recognition changes how your brain operates. You are no longer trying to invent a new solution. You are simply adapting a proven, pre-existing strategy to the task at hand. However, even the best patterns are useless if you can't recall them under stress. Technical knowledge is highly vulnerable to the forgetting curve. Solving a complex dynamic programming problem today is no guarantee that you will remember the solution for an interview next month. To prevent this, you need a revision architecture. This is a mock-up of a needs revision list within your testing platform. You must follow a strict workflow. Any problem you fail to solve on the first attempt, or any problem where you had to check a hint, goes directly into this list. You should also maintain an external, tagged bookmark folder in a tool like Notion. Use this to archive high-quality tutorials that explain the why behind the patterns you've identified. This revision list is not optional. It must become your mandatory daily warm-up routine before you attempt any new problems. This retrieval process ensures that the thousands of hours you invest actually translate into permanent, on-demand knowledge that scales as you learn. You now have a 3-pillar architecture: a progressive path for difficulty, a system for grouping patterns, and an automated loop for retention. Mastering this system takes time. You will likely spend weeks or months feeling stuck, but with consistent repetition, these complex structures will click into place, becoming a predictable, manageable part of your toolkit. When you hit a wall, leverage the discussion forums. See how others have navigated the same constraints, rather than abandoning the system. Your next step is to begin populating this system today. Start by researching and studying the 15 most common problem-solving patterns.